Hello everyone, welcome to this video where we'll break down some of the most fundamental concepts in the operating system and programming languages. These concepts play a crucial role in how programming languages execute code. By the end of this video, we'll have a solid understanding of the following topics: user mode versus kernel mode, system calls, compiler, interpreter, and the Java virtual machine. We'll explain everything in a simple and easy to understandable way with real life examples. So let's get started. User mode versus kernel mode. To understand how a computer functions, we need to understand about two important CPU modes, user mode and kernel mode. These mode determines what a program can and cannot do while running on a system. Think of it like a car. User mode is like sitting in the passenger seat. You can give directions, but you don't have full control. Kernel mode, on the other hand, is like being the driver. You have the full control over the car, including the ability to start and stop it. User mode is most of our everyday applications run. Programs in user mode cannot directly access the hardware like CPU, memory, or disk drives. Instead, they have to ask the operating system for help whenever they need to perform tasks like reading a file or sending data over the internet. For example, when you open a web browser, it is running in user mode. If the browser wants to save a file, it cannot directly write into the disk. Instead, it makes a system call, making the operating system to do it on its behalf. Kernel mode is where the operating system runs. This mode has a full control over the hardware, allowing it to manage memory, process, and device communication. For example, when you press the power button on your laptop, the operating system loads into the kernel mode. It manages the CPU, starts background services, and ensures all the hardware components are working properly. Since the kernel mode has a complete access to the system, if a program runs in the kernel mode crashes, it can crash the entire system, causing a blue screen error. System call. Since user mode cannot directly access hardware, they rely on something called a system call to request services from the operating system. For example, when a program wants to open a file, it cannot directly access the hard drive. Instead, it makes a system call to the OS asking it to handle the file operation. A simple analog is ordering a food at the restaurant. As a customer, you cannot just walk into the kitchen and cook your own meal. Instead, you place an order and the chef prepare the meal for you. System calls can be categorized based on what they do. Some system calls can manage process, other handle files, and some deal efficiently. Compiler versus interpreter. Programming languages like C, Python, and Java are written in a high-level code which computers cannot understand directly. They where compilers and interpreters come in. The main difference between the compiler and interpreter are execution is compiler translates entire code before execution. In interpreter translates line by line. Speed is fast in compiler. Speed is slow in interpreter. Examples of compiler are C and CPP. Examples of interpreter are Python and JavaScript. Debugging is difficult in compiler. Debugging is easier in interpreter. Compiler. A compiler translates the entire program before execution. This means once the program is compiled, it runs much faster. However, compilation itself takes time. A real-world example of the compiler is book translator, who translates the entire book before giving it to a reader. Interpreter, on the other hand, translates code line by line and executes it immediately. This makes it slower than a compiler, but easier for debugging. Think of it an interpreter as like translator. Instead of translating a whole book, it translates each sentence as you speak. JVM, the Java Virtual Machine, is what makes the Java unique. Instead of compiling the code for a specific operating system, Java is compiled in an intermediate form called bytecode, which can run on any system with JVM. This by Java follows the write once run anywhere principle. JVM works by using the steps. Java compiles, converts Java code into bytecode. The JVM interprets the bytecode into the mission code. The code runs on any system with the JVM installed. Summary. We explored how the user mode and kernel mode works, how the system call enables communication with the OS, and the difference between the compilers and interpreter. And finally, we learned about how the JVM allows the Java programs to run on any platform. I hope this video was helpful. If you liked it, please like, share, and subscribe for more educational content.